Welcome to the first lesson in Module 1. Cellular IoT is already embedded in industries you interact with every day, from the smart meter on your building to the tracker on a shipping container crossing the Pacific. By the end of this micromodule, you will be able to identify the major industries deploying cellular IoT and explain why it has become the connectivity backbone for billions of devices worldwide. Let's start with a big picture view. Cellular IoT connects devices that operate over wide areas in remote locations or in environments where running cables or relying on local Wi-Fi simply is not practical. The result is a technology that cuts across nearly every major industry. That's where scale kicks in. The cellular IoT ecosystem supports over 18.5 billion connected endpoints in a market worth over $1 trillion. This is infrastructure at global scale. Electric, gas, and water utilities were among the earliest adopters of cellular IoT. Millions of smart meters now report consumption data back to utilities automatically, eliminating manual meter reads and enabling real-time demand management. Utilities deploy millions of smart meters in basements, underground vaults, and rural substations. These meters report consumption data once or twice a day and must operate for 10 plus years on a single battery from locations buried behind concrete. NB-IoT excels here with its 164 decibels maximum coupling loss, the deepest indoor penetration of any cellular IoT technology. Its narrow 200 kHz bandwidth and transmission repetition capability punch through environments where other signals cannot reach. At module costs of $5 to $12, it scales to deployments of hundreds of thousands of units where every BOM dollar matters. If something moves and has value, someone wants to track it. Shipping containers, pallets, vehicles, construction equipment, and even medical devices are tracked using cellular IoT. Unlike GPS alone, cellular connectivity lets the device report its location back to the cloud in near real time, no matter where it is, on a highway, at a port, or in a warehouse. Think about a shipping container moving from a factory in Shenzhen to a warehouse in Rotterdam. That container needs to report its GPS position, internal temperature, door open events, and shock readings as it travels by truck, ship, rail, and truck again. Wi-Fi hotspots do not exist in the middle of the Pacific. Cellular connectivity, particularly LTE-M, gives that container a persistent data link wherever there is a cell tower. Beyond ocean freight, last-mile delivery fleets, construction equipment operators, and pallet-level tracking all use cellular IoT. The common requirement is mobility. LTE-M's cell tower handover keeps devices connected seamlessly, even at highway speeds. The business impact is tangible. Reductions in cargo theft, faster cold chain compliance alerts, and lower dwell time at distribution centers. Remote patient monitoring devices, blood pressure cuffs, glucose monitors, cardiac sensors use cellular connectivity to transmit health data to clinical platforms. Cellular is preferred here because it works independently of the patient's home Wi-Fi, which reduces setup friction and improves reliability for vulnerable populations. A patient wearing a cardiac monitor at home, at the grocery store, or visiting family across the country cannot depend on a specific Wi-Fi network. Cellular provides continuous coverage wherever the patient goes. LTE-M is the technology of choice because it supports both data and VoLTE voice, critical for personal emergency response devices that need two-way voice calls with monitoring centers, not just data packets. Medical devices also benefit from cellular's carrier-grade security. SIM-based mutual authentication and encrypted bearer channels meet regulatory requirements that consumer Wi-Fi networks often cannot guarantee. Farms span thousands of acres with no Wi-Fi and often no wired power. Soil moisture sensors, weather stations, livestock trackers, and irrigation controllers deployed across farms and ranches rely on cellular IoT. These devices are often spread over hundreds of acres with no Wi-Fi infrastructure in sight. Cellular gives them wide area coverage without requiring the farmer to build and maintain a private network. Cellular IoT sensors monitor soil moisture, weather conditions, irrigation systems, and livestock location. A soil moisture sensor sends a 50-byte reading every 4 hours. A livestock GPS collar reports hourly. The data is small and infrequent, but the coverage area is enormous, a natural fit for LPWA technologies. A practical challenge is that many farming regions have limited cellular coverage. Low-band spectrum below 1 GHz provides the best rural range, making band support a critical hardware design decision. A device supporting only high-band frequencies may work in suburban testing, but fail in the field. Connected streetlights, parking sensors, air quality monitors, and flood sensors share key characteristics. Outdoor deployment across a citywide footprint, no access to wired Ethernet, and multi-year operation with minimal maintenance. Cellular provides the wide area coverage and infrastructure independence these deployments require. These deployments also highlight cellular's operational advantage at scale. Centralized fleet management, monitoring 50,000 connected streetlights, pushing firmware updates, and diagnosing issues remotely is far simpler through a single cellular platform than a patchwork of local Wi-Fi networks. The scale of these deployments, often thousands of devices spread across an entire metro area, makes cellular the natural choice. Factories use cellular sensors for vibration monitoring, predictive maintenance, and environmental monitoring. Vibration sensors, temperature probes, and pressure gauges report data to predictive maintenance platforms. In brownfield environments, older facilities without modern networking, cellular avoids the cost of running Ethernet or deploying industrial Wi-Fi. These sensors are often retrofitted onto equipment that was never designed for connectivity, and running Ethernet or installing Wi-Fi in factory environments with metal structures and electromagnetic interference is often impractical. In newer deployments, 5G RedCap is gaining traction for its network slicing capability, dedicating a low-latency virtual network slice to safety-critical sensors, while routine telemetry uses a separate best-effort slice. This ensures a burst of bulk sensor data never delays a safety alert. Smartwatches, personal emergency response devices, and pet trackers use cellular IoT to maintain connectivity independently of a smartphone. This is especially important for safety-critical applications where the device must be able to call for help or share location even when no phone is nearby. What do these industries have in common? Across all 7 industries, cellular IoT is chosen when the device operates outside the reach of Wi-Fi, outdoors, underground, or in transit. No local network infrastructure can be installed or maintained. Multi-year battery life is required. Carrier-grade security or quality of service guarantees are needed. The deployment scales to thousands or millions of devices. Cellular IoT is not limited to one vertical. It spans utilities, logistics, healthcare, agriculture, industrial, cities, fleet management, and consumer wearables. The common thread is this: these are devices that need wide area connectivity, long operational lifetimes, and the ability to work without relying on local network infrastructure. In the next micro module, we will dig into exactly why cellular is chosen over alternatives like Wi-Fi and Bluetooth Low Energy.